Hi, in this video lecture, we're going to solve a Hackerrank problem, insert a node at the tail of a linked list, which is under data structure sections and subsection of linked list. Let's quickly read this question out here. You are given the pointer to the head node of a linked list and an integer to add to the list. Create a new node with a given integer. Insert this node at the tail of a linked list and return the head node of the linked list formed after inserting this new node. So we are supposed to create a new node, attach it at the tail. It also says that the given head pointer may be null, meaning that the initial list will be empty. You have to take care of inserting at the rear when the list is empty as well as when the list is non-empty. There is a function called as insert node at tail. The prototype of that is already provided. You need to complete that particular function, and that function has two parameters. One is a pointer of type single linked list node, which will be pointing to the head node of the list. And the another one is data, which will have the value what you want to insert in the data part of the new node what you create. And we need to return the updated head pointer. And you don't need to worry about this particular portion wherein n is 1 to 1000 and every element of that could be between 1 to 1000. So invoking the function multiple times, that is n number of times, is taken care by the main function which is already provided, and your job is only to write the function part of insert node at tail. I've already solved a problem like insert node at head, wherein I've explained in detail about every step, like what is this particular pointer, what should we return and everything. You can watch that video before looking into this. And as usual, I will try to solve this problem in another platform wherein I'll try to demonstrate with visualization, and then I'll try to copy paste this code and put it into Hackerrank. So I already have a header files out here, and then the structure of a node, as well as the function first line, which contains the return type, the name of the function, the parameter list. And inside this, the first task what you need to do is create a node. How do we create a node? With the help of malloc, because the node has to be created dynamically. And for malloc, we need to specify how many bytes to allocate. We'll try to use size of operator to get to know the size of the structure. And this will reserve the memory for one node, and that has to be collected into a pointer. So I'll be collecting into a pointer of type singly linked list node. And let me just give a name for this. I'll just try to call it as new node. Wherein I'll just use the camel casing. Really? Okay. Now, again, the memory allocation could be successful for failure. I'm assuming that the memory allocation is successful, so I'm not verifying if the allocation is successful or not. Now, once the allocation is successful, we need to initialize the node. In the node's data part, I'll be filling it with the parameter value data, whatever you have passed, and the link part of this, or also called as the next part, I'll be setting it as null. So allocating of the memory and initialization is done. Now we need to think of how do we attach this node. If the list is empty, that is, if this pointer, which is pointing to the list, if this pointer is null, this is my first node. Okay, meaning the list is currently empty, and whatever you created now is the first node of the list. And you will just say, okay, fine, the list was empty. This is new node created, and this itself will be the header node. So I'll just try to write list equal to new node. But what about in case if the list already consists of some elements? In that case, we need to use another pointer traverse till the last node. So I'll be using one more pointer, and this pointer I'll be using it to traverse till the last point. So there'll be a temporary pointer, or you can also call it as last. And initially it will be pointing to ls, which is the first node. I need to traverse till I reach the last node. Remember, on reaching the last node, I need to stop. So I just try to write last of next not equal to null. Important point to understand that last of next, meaning if I don't mention this, it will only stop after jumping out of the last node. But what I want is on reaching the last node, I need to stop. Okay. And I'll just keep updating this pointer. Okay, you have not yet reached the last, find no issues. I will just try to write last equal to last of next. Okay, just to save some spaces out here, I'm just trying to remove this, but it's always recommended that you use flower braces even if there's one statement in the block. Now, once you reach the last node, you can just make the link of the last node point to the new node. That's it. So now this gets attached. Once it is attached, the next thing what you can do it is you need to return the updated head pointer, return list. That's it. So here I'd like to call this function multiple times. The first time when I call this function, the list will be empty. So I'll just try to write head equal to. So why exactly I'm collecting back this into head? For this, again, you need to watch the video, insert node at head. And I'll be passing some value out here. Second time, when the list is not empty, I'd like to call with some value. The value can be lesser, it can be greater, anything. And third time, again, I'm just trying to pass this. So I'm going to verify with 3 nodes. Let me start visualization out here. Execution starts from the main. And in the main, we are basically setting the pointer to null. The head pointer to null. You can just observe this line number 28 had made this pointer to null here. I'll be invoking the function insert node at tail, which has a parameter list, which will receive the value what is passed. You're passing head, which is null, and data, you're passing that as 45. And then line number 12 is going to allocate a new block of memory for a node in the heap section. And since I'm using malloc, the data is not initialized. And the next 2 statements will basically initialize with the whatever the data you have passed on. And now I'm going to verify is the list is empty or it already consists of nodes. And on verification, we observe that the list is empty. Since the list is empty, I'll try to execute line number 17. And after that, I will just return this list. So now when I try to return this, remember the head was null. Okay, now this node was created and this same information what is there will be returned and will be received in this particular head. So you can just observe. You want to have a more detailed view with the addresses, you can always see a more detail with the help of show memory addresses. So this is what. And one more great thing of this particular tool is you can also go in the previous direction. You can not just step forward, you can also step backward. See, I've moved in the backward direction. This pointer was pointing to this node in the heap and the address was 2040, which is in the heap section, and head was null in the main. So on returning it, so you will observe that all the local variables of the main will be, the function will be deleted and the head will collect this information, will be pointed to the heap block. Second time when I try to jump in the function, same way you try to create a new node and you initialize the node with the values. And now you want to check is the list is empty? No. So I need to traverse. So I'll just use one more pointer called as last, which will initially point to the same place where list is pointing. List is pointing to 2040. So last will also point to that. After this, I'll just check out, is this pointing to the last node? Is it my current last node? Yes. Why? Because the next part of the last node will be null. And since it is already null, so I'll just not enter inside the while loop. I will come to line number 23. And here line number 23 will make the link of 45 point to the newly created node. The link of, okay, this one, you can just, I hope you can observe this, the next out here. This will point to the newly created node and the newly created node's address is 2090. So you can just observe this how it looks like, right? So when I move back to the main, so, okay, what happens out here is list is pointing to 45 itself. So there's no change in the head, but it's pointing to 45. The link part of 45 is pointing to this node 12. Now, when I call this function the third time, again, you create a new node. You initialize the data part and the link part. And if the list is empty, no, list is not empty. You create a pointer called as last, which will again start from 45, that is first node. And then, is that the last node? No, this is not my last node because the pointer is not pointing to null here. So I will enter inside the body part of the while loop. I'll update that to point to the next node. Which is my next node? This one. It's going to point to this now. This pointer will point to this place, right? Now I'm going to check out, is this my last node? Yes, this is my last node. So don't go any further. Now come out of the while loop and modify the link of the current last node, which is 12, and then make it point to the newly created node, right? And once you do this, you return the L list. L list is still pointing to the 45 itself. There's no change. And this is how your linked list will look like. You will be pointing to 45, 45's link is pointing to 12, 12's link is pointing to 67, 67's link is pointing to none. So this is the overall code what you need to do. I will try to take this particular code snippet and I'll try to put it in Hackerrank. Copy this and then just trying to paste this here. I'd like to, here the parameter name is head. Okay. I just try to run this. Pass the sample test cases and then submit the code out here. All the test cases are passed. So I hope the concept is clear. I have used a tool called as Python Tutor. The link of this one will be given in the description section. You can always use this tool to perform step-by-step execution and understand the flow of the program. Thank you.